office. I'd like to now thank one of our most loyal supporters, a perennial sponsor of this festival, Enbridge Gas Distribution, and I'd like to ask Dave Teichroeb, technology guru, I wrote that, at Enbridge, to come up and speak and to introduce our morning keynote speaker.
Oops. Thank you, Larry. Much appreciated. And it's a pleasure to be here this morning. Enbridge very much appreciates the opportunity to be one of the sponsors for today's event. And you have a host of presenters and panel discussions that are going to really stretch the boundaries for topics ranging from sustainability, but going the gambit all the way through to new innovative design principles and building resiliency. Now, for a few of my comments, I just wanted to touch on what I believe is a view Enbridge is learning from our customers, our partners in the industry, and this is really about being a company that strives to deliver the energy that people want and need. But I do want to touch on the opportunity that I see before us, which is to make buildings part of the solution, not part of the problem as they're viewed today. We have an opportunity that's the trifecta of building energy performance before us. This is one where buildings are more sustainable because they truly have a lower carbon footprint, either directly or how they interact with the larger community. This is one where homeowner affordability is at least maintained or enhanced. And this is also an opportunity where we have increased energy resilience. Not just in a small way, but one that really stretches the boundaries for where we want to be. And this evolves from a host of technologies that can be integrated, from solar PV, battery storage, micro-combined heat and power. Not looking at these in isolation, but how they interact together. And more importantly, how they interact with the bulk power grid all the way back to the wind, solar, hydroelectric resources that we've got driving that grid. And so this is the opportunity that we have. And it also needs to be put into perspective from different pathways we can tap in how we decarbonize our bigger economy, but also how we enable the buildings to take advantage of that. So we tend to think in terms of simplistic sound bites. Deep decarbonization, increased electrification. Net zero energy, not necessarily focusing on emissions, but just energy. If instead we start to look at building a portfolio that allows us to get different energy supplies to consumers, leaving consumer choice into how they incorporate that with their buildings, it all starts with very deep energy conservation. We're not talking today's approach to energy efficiency. We're talking something transformative so buildings use physically 40, 50% less energy, whether they be retrofits or brand new state-of-the-art construction. But we have an opportunity then, once we've reduced the actual energy use in that building, to then go the next step with advanced technologies like heat pumps, not just air source or geo, natural gas heat pumps, hybrid heating systems, as Natural Resources Canada would say, where the energy that is needed in that building is further reduced by 40% or more through these state-of-the-art appliances. And then we have an opportunity that's really not talked a lot about now, but we've done a very successful job, at least here locally, at decarbonizing our electric grid over several decades. We have an opportunity to do the same with our pipeline network. And so those first two measures, coupled up with about a 40% reduction in the emissions from the natural gas pipeline, and this is by adding more renewable content, this can deliver 80% GHG reductions by 2050. And it's not that this is the pathway, this is a complementary approach though to the other measures that are being pursued with net zero and also with deeper electrification. Now, I spoke of conservation. We know conservation pays dividends today. It's very cost effective. It puts money back in the pockets of consumers. But we're talking about a transformative approach here where deep energy efficiency measures will incorporate that improved thermal envelope. There's going to be design principles that need to be embraced. We're going to have to train the trades. This is all going to be important to delivering this so it actually works into the buildings. Improved window fenestration. The performance of those windows needs to make a step change, and that'll happen through building codes, but also through the manners in which they're installed and applied and designed into the structures. And finally, we have an opportunity for, yes, improved insulation standards, but particularly in things that are difficult, like the retrofit market. There are technologies evolving in improved building skins that could be retrofitted to improve the thermal envelope yet again. The challenge is getting all the trades and the technicians and the designers schooled on this so that it's easily deployed and more repeatable than just one-off projects as well. Now, I want to just ground everyone on how real the concept of renewable pipeline fuels is. If we're to say this is an option for how buildings can also decarbonize their footprint, then how real is it? And today, the most simple approach to renewable natural gas is things like landfill gas, wastewater treatment plants, and also green bin organic programs. All of this can be harvested, turned into a biofuel that's clean to pipeline standards and injected in the pipeline where we have readily available storage. Now, that gets us started, but we then can start to look at how biomass is gasified and cleaned to pipeline standards. CO2 in the future becomes not a pollutant but a resource to be harvested. And when combined with renewable hydrogen, we have the opportunity to make synthetic renewable fuels. Now, that looks like a real stretch, but I can tell you this is real. It's happening in Europe. We just need to approach things differently. And in general, these renewable fuels are very cost effective against other types of renewables. Don't compare it to conventional natural gas prices, but if you're just trying to gain renewable access for consumers, these are very cost effective. Now, the other one that comes to bear is power to gas energy storage. Enbridge and some of our partners are working to deploy the first of these technologies here in North America in Markham, Ontario. And this is a technology that takes something called an electrolyzer. And think of it as a new intertie. We talk about interties between Quebec and Ontario, Ontario and New York. We have an opportunity to build an intertie between our electric grid and our wholesale natural gas grid. And rather than curtail wind, spill water over a dam, or export these resources to neighboring jurisdictions, we can contain that energy in our own backyard for our own competitive advantage. And that technology today can take surplus power, off-peak power, convert it to green hydrogen, inject it into the natural gas grid as another way of building renewable content, and at the same time provide grid stability services. It's not well understood, but the natural gas energy network and its related storage is probably the most cost-effective and distributed energy storage battery in the province. We spend 6 months of the year packing up storage to deliver it to consumers over 60 to 75 days of peak winter. Buildings are still going to have that seasonal profile. Take advantage of this infrastructure. Use it for its cost effectiveness. Just green it and bring it so it complements the wires. It complements what the buildings provide in solar PV generation. All of it plays a role at getting to the next stage, which is physically integrating these technologies into the building. And so when we look at solar PV, yes, we can put up a very large solar PV array. We can export a lot of that energy to the grid in the summer and the spring. We can take it back in the winter, but we may not be getting renewable energy back in that peak. The opportunity is to right-size this. Match it up with some battery storage, but modest amounts of battery storage because it is costly. Match it up with micro-combined heat and power. And we now have a seasonal matching. Strong solar irradiance in the summer and spring, matched up with very efficient use through combined heat and power of conventional gas and renewable gas in the future, and now we're decarbonizing both the electric and the thermal aspects of that building. They all play a role in right-sizing it to reduce first cost of the building, and more importantly, reduce the cost to ongoing operations and to the bulk energy infrastructure. So this is getting to another aspect where that type of, call it portfolio approach, will greatly enhance the resiliency of these buildings as well. And so it brings me to something that Natural Resources Canada calls dual fuel systems. We used to consider that maybe it was a greenhouse with natural gas and it backed itself up with oil. In the future, the dual fuel system is electric and gas. And I've termed it hybrid heating. We all understand the benefits of the hybrid car. But we have an opportunity now to put air source heat pumps and natural gas high efficiency solutions together. But it's not a dumb heat pump installation. It's not one where at a certain temperature we switch from the heat pump to gas. No. Instead, we integrate this, we interrogate what's happening for carbon emissions in the bulk power system, and we dispatch these appliances based on trying to impart change in the bulk energy system. Think of a March day. It's the middle of the afternoon, strong solar irradiance. We've got maybe even surplus power. The heat pump's performance would be good. Instead, we run on the heat pump. Switch that around to a January evening, people coming home for dinner, set back thermostats in the building coming off. The peak power grid's ramping up in the bulk power grid. Gas plants are starting to run, but less efficiently than direct use of appliances in the home. Switch that to gas. Homeowner doesn't want to think about it, but that's dispatched remotely to achieve carbon reductions based on that dual fuel capability in that home. So we run the air source heat pump when we have adequate renewables. We switch to direct gas when we don't. We have more affordable GHG reductions, and more importantly yet still, it's easier to build resiliency in because you've got two input energy choices and you don't have to overbuild the electrical bus in the building, the bulk power grid, the battery storage, etc. Far more flexibility on all of those measures. And finally, making buildings part of the solution. Virtual power plant capacity. Some of you will be aware of this through discussions around microgrids. But think in terms of not one or two buildings, but thousands, tens of thousands of buildings fitted with solar PV, battery storage, micro-CHP, hybrid heating, all brought to bear and dispatched remotely without the homeowner having to think. Now we can start, depending on what happens in the bulk power grid, have buildings soak up surplus renewable electricity rather than export it or curtail it. It soaks it up like a sponge. Likewise, when we're running short on renewables, we have the most efficient use of energy going in and displacing what would have to come all from the power grid. And at 10,000 homes fitted with that hybrid heating solution, you have 50 to 100 megawatts of flexibility that can be brought to bear for your local utility or even the independent electricity system operator. For Union and Enbridge, who connect 50,000 customers a year, if we can transform the design of our buildings, the HVAC industry, to adopt some of this, you could very quickly bring about 100, 300, 500 megawatts of flexibility, all that can be tuned to reducing carbon emissions. So I hope I've left you with a little bit of a different perspective, something that can kick off the day for some of the more in-depth discussions that you'll have. And with that, I'd like to introduce our keynote speaker for the opening panel.